About the second question, we need to collect the definition of properties of stochastic process. The first one is wide sense standard process. We can see that a stochastic process is called a wide sense standard process if its mean is a constant and autocorrelation is a function of time difference. It means that the mean equals to constant and the autocorrelation equals to this. And the second one is independent increment process. It means that xt1 minus xt2 and xt3 minus xt4 no overlapping intervals are independent. And the third one is Merkle process. We call it is a Merkle process if the past has no influence on the future when the present is not. We see that a Python process is a Merkle process. In the real world, many processes have Merkle property. And next one is normal process. A process xt is said to be normal if the random variable xt1, xt2, xtn are jointly normal for any n, any t1, t2, tn. That is this function, and this is the function. And the next one is strict science stationary process. A process is said to be a strict sense stationary process if it's static, if its statistic is not affected by shift on the time axis. It is SS process. It requires that the probability density of xt1, t2, tn, x1, x2, xtn, and t1, t2 to tn equals x, the probability density of xt1, t2 to tn, and t1 minus t1 plus a period of time. It means that you can shift the time axis, and you could get the same result. And the next one is white noise. Stochastic process Vt is said to be a white noise if the expector of Vt equals 0 and autocorrelation function equals qt1 and multiply and times implies of t1 minus t2. And the last one is mean ergodic process. A stochastic process xt is called ergodic if or is statistic can be determined from a single sample. And what is mean ergodic? Xt is said to be mean ergodic if it satisfies this function.